Right, question 17. So this is like, I suppose, an introduction to logs, or to remind you again about what logs are. So if we look at number 17 here, it says log to the base a of b is equal to x. So the question says in part A, express b in terms of a without involving a logarithm. Okay, so here you've got a and b involved here, but there's a logarithm here, so they want now b in terms of a. And what we got to remember with the logarithm, okay, it's all about working out what the powers are, okay. And you see with, for instance, question B here, part B, you want to solve this, for instance, in part B, where the power is the unknown, the x. We want to know. Logarithms are really useful for working out the powers, and you need to realize here that when you've got log to the base a of b, x is your power, okay. That's really important. This is the power. Alright? And this little thing here, this is the base. Okay? So this is what you raise to this power x. So we could think of taking that a over the other side. Okay? So then it will be a to the power x. Alright? So I can rewrite this as taking the a over the other side. A is the base to the power x. And of course, you're just left with b here. Then the log disappears. Once you take that base over, the log goes. Okay, that's just the effect of a logarithm and working with logarithms. So you take the a over, okay, and a is your base. Don't forget the number that you will be raising the power to, and that is your power. Okay, so the answer to your logarithm is always your power. So you take the base over to the power x, and that will equal b. And we've answered the question. We've expressed b in terms of a without involving a logarithm. So part B then, okay, it says show two ways of solving 2 to the x equals 14. And what we can do here, there are two ways, okay. The first way is just using this idea here, okay. Now remember, x is our power, alright, 2 is our base, yeah. So then the logarithm gives us the power, right? Gives us the answer, the power here. So considering we want the power here, we could, for the power x, take this base over the other side, and it creates this logarithm to the base 2, which equals 14. So you can see I've gone opposite to what's gone on in part A. All right, here's my base, that's my power. I could take it back if I wanted to. 2 to the power x. Okay, so it's using logarithms now to actually work out x. You can actually work this out in your calculator. Okay, there's a button there for, let me show you, there's a button there for logarithm with different bases. So I can put logarithm base 2, and that equals 14, 14 there. And we put that in, and we get our answer 3.81, okay? 3.81. Now that's one way of doing it, but it does show two ways, okay? This is the question that I've made up, and I want to show you the other way. Now the second way is the most popular way, and this is the way I would recommend you doing it if you've got a question like this. So when I've got this here, okay, and what I would do is I would take logs of both sides, okay? So taking logs of both sides, right, I'll just write that down, take logs, okay? So take logs of both sides. I'll have log 2 to the x equals log of 14, right? So I'm taking logs of both sides. And what I can do then is, once I've taken the log of this, I can use the rules of logs. Now one rule of logs is, if I've got a power here, I can bring it down in front and multiply. So I can bring that power down, and I've got that then simply. And then to get x, all I've got to do then is, because I'm timesing x by log 2, I can just take it over the other side and divide by log 2. Okay, so if I do that on my calculator, I should get the same answer as I had in the first method. So the answer comes out to be exactly 3.81, exactly the same. Now I would recommend you use this method because it's one that you can easily remember, okay, and it's much more straightforward when the powers are more complicated. We'll see that in a few questions now going along, question 18, 19 and so on. So this method I would highly recommend. Okay, let's just do part C here. So it says express as a single logarithm, okay? Now express this as a single logarithm. What we need to do here, okay, is use our laws of logs. And when you're adding logarithms, okay, log 2 add log 4, okay, this is the same as a single log where you actually times the terms, okay, so this will be log 8. So you would have learned this in terms of the laws of logs. This is the first law you would have learned. When you're adding two logarithms, you can times the terms and to make it in as one log. Part 2 then, if you're taking away logarithms, now taking away means that we actually put it as a single logarithm, but you end up dividing, okay? So you divide them, so that would be log to the base a of 3, alright? Now notice the similarity here between indices. When you multiply terms, you add the powers. And kind of adding here, aren't we? When you divide terms, you take away the powers, and you know, we're dividing here and we need links to that. Okay, now number 3 then. Right, this is a single log. Now we've got a number in front of that log. We want to get rid of it. So what you can do, because you're timesing it by that log, you can take it up as a power. So it'll be log to the base a of 2 to the power 3. And of course you can work that out. Log to the base a and 2 cubed is 8. And you've got your answer.